Last lesson we learned how to find the solutions to a quadratic in factored form in particular. Here's an example, using the zero product property. So as a quick reminder before we jump into today's lesson, which is going to be similar, but we're going to learn another method to find solutions, I want us to reconsider what x-intercepts are. So again, x-intercepts are the numbers for x, the values for x, that allow the function to be equal to 0. So again, these are the x values that allow the y value to equal 0. Whenever the y value is 0, that means the point lies on that x-axis there. The y value is equal to 0. And because of this, the x-intercepts are considered solutions to the quadratic. So whenever you're asked to identify the solution to a quadratic, you are essentially being asked, what is the x-intercept? What is the value of x at the x-intercepts of that quadratic? So far, we learned last lesson that we can easily solve these solutions using the zero product property from factored form. So here's just a quick example to recap what we did last lesson. Here we have a quadratic in factored form. We know to find the solution, we need the equation to be equal to 0. So it's set up equal to 0. And then, because it's in simple factored form here with just the two factors, nothing else, I can easily set each factor equal to 0 and solve for the x value that would allow the factor to be equal to 0. For example, and the way this works is because if x minus 1 is equal to 0, then x plus 2 times 0 would allow my function to equal 0 because anything times 0 is 0. So if I have an x value of 1 minus 1 is 0, it does allow this whole function to be equal to 0. And same thing with the other factor. If I have an x value of negative 2 and add this to 2, then that would make this whole thing equal 0, and 0 times x minus 1 would still be 0. So there's two values of x here that I saw from factored form that I could plug into my formula here and allow the function to be equal to 0. So here I have two solutions. But what we're learning today is, what if it looks a little different? Here we have a quadratic in factored form, but there's an added term. Unfortunately, I cannot just easily use zero product property and find the solution. So for example, my solutions here are not negative 5 and positive 4 because I have this added term. What we still want to do is we are still finding the solutions for x when the function is equal to 0. So the first thing to always do is set your equation and make sure that on one side of your equal sign you have a 0 and only a 0. So I'm going to rewrite this as 0 equals x plus 5 times x minus 4 minus 3. What we're going to learn today is actually going to be how to use Desmos, the technology we learned last week, to find the solutions by looking at the graph. So I'm going to show us here how to use Desmos. You would want to go to desmos.com graphing calculator, and then we're going to simply type in our equation. We don't need to type in the 0 equals, we're just going to type in this quadratic here. So I have x plus 5 times x minus 4 minus 3. This is equal to 0. It's all set up well. Everything's on one side away from the 0, so we're good to go. So I'm going to look at my Desmos here, and I'm going to type in that formula. So I have x plus 5 times x minus 4 and minus 3. So what I've done here is I've actually graphed this in Desmos exactly how it appeared on my paper, and this is what I have gotten. So this is what my graph looks like. From this graph and using this technology, I can easily identify what the solutions are. And so what you're going to do here is we're looking at the x-intercept. So I have a solution on this gray dot, my x-intercept at 4.322. I have one more x-intercept solution at negative 5.322. Now, these are some weird decimal points. That's totally okay, but the great thing about using this technology is we don't even have to estimate. It will give us the exact value with decimal points. But the key thing to see here is that I have two x-intercepts. So this quadratic has two solutions, and I can go ahead and write those down on my paper as my answer. So again, I have an x-intercept at negative 5.322 4.322, and notice how at this x-intercept, my y value, my function is equal to 0, which is exactly what we want. I have one more x-intercept where it's crossing this x-axis here, the line going side to side, at 4.322. So I have two solutions here, which I can note on my paper. So I was able to solve this, not by any crazy math, but simply typing it into Desmos and identifying it from the technology. It seems somewhat simple and that the computer is doing all the work for us, but being able to use this graphing technology is actually very important. All right, now we're gonna look at another one. So here I have a quadratic set up as -4 times x minus 1 times x plus 2. The difference here, the problem here, is that not only do I have another value outside of just my two factors, but my equation is not set up to be equal to 0. So in this format, I cannot solve for my x values for what would give me the equation to be equal to 0, which is what I need for my solutions. So whenever you have a function in this format that you do not have a 0 on one side of the equal sign, we need to make it 0. So what can I do, inverse operation, to get rid of this -4 that will allow my function to be equal to 0? Again, I'm using the inverse operation, so instead of -4, to cancel it out and have it be equal to 0, I need to add 4. So I'm making sure there's opposite signs here. What I do to one side of my equation to keep it equivalent and not actually change the value but just change the format, I must do to the other side as well. So I'm going to add 4 to both sides. -4 plus 4 is equal to 0. And there we go. That's exactly what we want. We want one side to have a 0 only. Then I have x minus 1 times x plus 2, and I have my plus 4 on the outside. So again, I cannot solve this easily by just using the zero product property and flipping these signs because I have another value here. So again, I'm going to solve this by graphing. I'm going to use my Desmos technology. And we're going to get rid of this old one here and type in the new function. So I have x minus 1 times x plus 2. And then on the outside, I had that plus 4. Here, I see my quadratic. My solutions are the values on this x-axis here that lead my function to be equal to 0. Now, does my graph actually ever cross this x-axis? Do I have x-intercepts? No, I do not. My graph starts above the x-axis and it's going upwards, so it's never going to actually cross this x-axis here. So by graphing, I actually know I have no x-intercepts at all. And so what I found out here from this technology is that there's actually no solutions. There are no solutions to this quadratic. So I'm going to come over to my answer sheet, and all I write are no solutions. And that's how we're going to use Desmos today in your next activity, student practice number 1, to identify how many solutions each quadratic has. Now, one more quick thing I want to show you guys is just an overall view of what quadratics look like when they have 0, 1, or 2 solutions. So, looking at this paper here, this is an example of a graph with one solution. It crosses the x-axis in exactly 1 point, and it has one x-intercept, so it sits on the x-axis. It does not drop below the x-axis. It literally starts somewhere from the x-axis at one exact point. So this is an example of a quadratic with one solution. This is an example of a quadratic with 2 solutions. Here you can see I have 2 x-intercepts, 2 places where the graph will cross the x-axis and the y values will be equal to 0 at those points. And here, what we just saw on Desmos as well, this is an example of a graph with no x-intercepts, therefore there are no solutions. It never touches this x-axis because it's starting above. So this would be a conclusion if I saw a graph like this, where just by looking at the shape, I can determine there are no solutions. So what you're going to do now in student practice number 1 is you're going to use the Desmos graphing technology to graph. Make sure, though, that when you have functions that look something like this, you are rearranging it first. So that might mean doing an operation of adding or subtracting a value so that one side is equal to 0. Otherwise, it's not going to work out, okay? So you need to isolate everything on one side so that you have the whole function equal to 0. Then you're going to identify how many solutions it has, whether it has 1, 2, or no solutions. All right, go ahead and get started, and feel free to watch this video again if you need it.